Hello everyone, let me know if you can hear me now. Let's hope that OBS doesn't keep crashing. Can you see me? Can you hear me? Let's try the stream delay, how bad that is. I'll count to 3 and then clap my hands. And when you hear it, just spam something in the chat. Okay, ready? 1, 2, 3. And then also let me know how the audio sounds compared to last time if you watched the previous streams, because now I'm using just my AirPods and I kind of want to try if the audio quality is worse or better. Because even though my big microphone is obviously a nicer microphone, it doesn't really have noise cancellation. I have a lot of background noise here, so let me know how this sounds now and if it's too loud or too quiet. Okay, then let me know how this looks, if you can see the text well. If not, I'm happy to make it bigger. Looks like something went really wrong here. Give me a sec. And I'll also put the chat on a second monitor so I can see you at all times. Okay, so now I can see the chat. You should be able to see the code. Something is really screwed up here though. That looks like half loaded or frozen. Oh boy. Am I well prepared today? For some reason now VS Code crashes. Let me try to see what I can do about that. Like, I installed a new extension earlier, which was actually supposed to help us with developing Rust, and it worked great earlier, and now it just crashes the whole editor. So let's start by debugging that together. Let's see if I can even open developer tools here. Nope. How can it be that bad? So the force quit did something. And now we at least see what the issue is here. Oh, now it seems to work. Okay, great. Sorry about that hiccup. So earlier today, I actually coded a little bit so that I would know exactly what we can start with. It seems like there's at least a couple of new people, so I'll very quickly summarize what we're doing in these live streams and kind of how far we got and what will be next. So in general, we're trying to implement pedestrians in Citybound with the kind of bonus side goal of implementing illnesses and how they spread. That's why it's called the Pedestrians and Epidemics live stream. I kind of gave the viewers of the live stream the choice in the beginning which of the two topics we want to focus on first. If we want to first model epidemic spread, like kind of among people who are at the same building, which is something that we could already do, or whether we want to first model pedestrians, which would be super useful for Citybound in general to have, and then implement epidemics later for pedestrians. And it seemed like most people wanted to do the latter, so that's what we're doing now. The caveat with that was that if we implement pedestrians, there's actually a huge topic that will touch a lot of parts of the game, will require a lot of changes in the code, and it will probably be quite a lot of work until we see something on screen. But knowing this, we just went straight ahead. And last live stream, we basically spent only coding. I think probably it will be the same today. I don't tend to work much on the topic that we do in the live streams in between, so that it's kind of more easy to follow and you can really see the whole process of building pedestrians as we go, and we more or less pick up where we left off. I did quite a lot of restructuring in between this time, just so we don't have to do a lot of annoying work while you're watching. But yeah, let me just tell you what is still left to do. I mentioned the last time that, or the way I went about it was that I basically looked at a lot of the code for roads and how lanes on roads work and how cars drive on them, and I just duplicated that, with the idea being that pedestrians will work very similarly to cars first, that they kind of just occupy a different kind of lane. And then I introduced that in the code, and basically just looked at all the errors that Rust gave me, because like it shows me where I still have something wrong, where I still have something not connected. This is like all the stuff with the red squiggly lines you see here. And one of the things I noticed in the last stream was that because Citybound is such a huge project, this approach is actually very slow, because every little change will take tens of seconds to recheck, and you don't really get nice feedback on whether you're making progress with integrating the missing new thing, in our case, sidewalks and pedestrians. But then a friend made me aware of a different Rust extension for VS Code, which actually checks much faster, and you will see it really checks fast, and that made the whole process and the restructuring I did earlier much more bearable and much nicer, in fact. So that's what we're going to start with today. We just kind of look at all the problems that exist and clean them up, and in the process, hopefully the system will kind of force us to implement all the things that we are still missing for sidewalks. With these kinds of things, it's always hard to predict how long things will take. My ideal goal would be that by the end of the stream, we have something related to sidewalks or pedestrians on screen, but I'm not quite sure how realistic that is. So I will just dive in and we'll start with some coding. And maybe during the breaks, I'll take some questions and answers of general nature that you guys might have. Anything unclear about this intro so far, or are you all ready to go? So while you're thinking, if you have any questions, I will just quickly go through these errors here again one by one and see what might be a good one to start with. Just to make sure, let me check the stream health. That looks good. Just so I'm not losing you guys, but I'm sure that you would complain. So let's see, we still have some cleanup work to do here with normal roads, where I generalized a bunch of stuff last time so that we could have logic that applies both to roads as well as to sidewalks. And in the process, I had to rewrite some existing stuff, and here's like some small leftovers. Whereas the rest of the problems currently shown in those files is actually directly related to sidewalks. I think I want to go ahead and just quickly try to tackle that so we have it out of the way and can then focus completely on sidewalks. So just give me a minute to think here what would be the best approach to get rid of this one here. This one is for the switch lanes, which are the invisible lanes in between two normal car lanes, which allow cars to merge between the lanes, or like switch lanes. That's why it's called like that. And in this connect overlaps method here, which in the past was past the ID of the neighboring two car lanes, we generalized that and said, okay, this isn't really something that's special to car lanes. This is actually a general behavior of something called an obstacle container, where lanes of any kind might interact with each other. Like a sidewalk might actually go across a road, and then the pedestrians on the sidewalk might be obstacles for the car road. So what we need to fix here is that now we don't know for sure anymore that the other obstacle container that our switch lane interacts with is exactly another road. And I'm just wondering if that really changes anything. But I think for now we can, let's see. Basically, we need to make sure that this is the case, that the other obstacle container is a car lane. There isn't a nice way to do that. I quickly look something up. Okay, this will be a bit ugly. So if other obstacle container as raw, and then I think I can check the type ID equals, so if this is a car lane ID, broadcast. So wait a sec, I think my screen froze and I probably didn't see anything that you guys were typing. because I'm using my iPad as a second monitor, which is pretty reliable, but apparently I'm kind of out of luck today. Okay, let's try that again. All right. I'm just taking a note for myself here how we can make this more beautiful. So basically, if the other obstacle container is not the car lane, then we just return. And now we know for sure that the other obstacle container is a car lane, so we can do so we just do a kind of ugly type conversion here now that we know that that's true for sure. And again, that is something that we can address later. And with that, we can put that other car lane here, and then it should check out. Let's see if it will like this. Yeah, that looks good now. I noticed that the type checking is still a bit slow now, probably because I'm doing the live stream and coding at the same time. And this is just a MacBook that I'm using. So here, I think we're just missing an import. And hunting down the bugs one by one. This is already in another method, which is very good. So here we just need to write that a bit differently. Oops, not like this, but into this, into and that should check out. Okay, I think like this, that should be correct. And that should be the last error related to the road restructuring. Everything else is already bugs related to pedestrians and sidewalks. So let's start with that. So the first thing we notice here that in this road prototype, which is basically it's a part of a plan that we do in the planning mode of Citybound, where the way it works is that the player inputs some gestures, which can represent roads or like lanes of roads or zones or pretty much anything the player can create in the game. We call those gestures. They often are associated with a path, and they represent some intent to create like a road or a zone. The planning engine then compares what the player wants to create with what already exists in the city, and based on the difference comes up with a bunch of actions that need to be taken. And in particular, it internally creates what are called planning prototypes, which is basically a more precise result of the plan that means something like, okay, here in this exact spot we need a stretch of road, like one lane from here to here with this length, with this width, or like here we need a building lot with exactly this shape. So the prototypes already represent almost exactly the thing that will exist in the game world once you implement the plan. And you can see that we have different flavors of road prototypes here. It can either be a lane that needs to be built, a switch lane, an intersection, or just a paved area. The paved area is really just for visual output. Like we don't really, it doesn't participate in the simulation at all. That just makes sure there's not only the virtual lane where the cars will go along, but that there's also visual representation. And we'll need to keep in mind that we actually also need to create these paved areas for sidewalks, and that they should get a parameter whether they should look like a sidewalk or look like a road. But that will already be when we try to get the sidewalks on screen. So for now, we just look here. We see that car lanes apparently have the spawn and connect method, which sidewalk doesn't have yet. So let's go ahead and look at the implementation of that. This is the automatically generated counterpart. So let's search for spawn and connect. We want the one here that looks like this in car lane. So what does it do? It's a constructor that takes a bunch of parameters. Basically, the first thing a lane does when you put it in the world, when you spawn it, is that it sends a broadcast to all other existing lanes, sending them their path information from where to where it goes, and then these other lanes can either connect as previous or next lanes, or as, for example, conflicting lanes on an intersection, or as lanes that you can merge between. And we need to implement the same kind of thing for the sidewalk. So let's for now copy that, go to our sidewalk implementation. Let's see where we have that. I guess we should do it also. I guess we didn't do that at all yet. So let's implement sidewalk. We want spawn and connect. It gets a sidewalk ID. It gets a path. Do we care whether it's on an intersection or not? I don't think we do. Let's see, we might need that. So timings, okay, this will stay the same. So instead of broadcasting to all other car lanes, actually we might still want to do that because we need to understand the overlaps, but let's replace this by sidewalk for now. We will later make sure that that we also get the interactions between roads and sidewalks, but for the beginning I just want everything to compile and to work once, and we see how much we already got right, and then hopefully kind of debug it with the running game. So we don't really care about this, I think. We have this report too, where basically for every plan that we implement, there's a specific manager that executes all the steps to make this plan real, and it, like, for example, calls the sidewalk spawn and connect constructor to create a sidewalk, but that might take some time, and that's why when the sidewalk itself knows that it's completely constructed, it will actually report back to the Citybound construction, it's called, that it's done. Well, and then we do the actual just like spawning. Is that the correct parameters? I think so. So that looks good. So now we have the spawn and connect method implemented here, and we get a bunch of errors because this actually doesn't return a car lane but a sidewalk. And here, okay, we don't have connect implemented yet for sidewalks, so we will again do the same. Are we missing something? Yeah, we have one parameter too much. Why is that the case? Okay, I think that's better. So Planet is actually a good question. I mentioned that when you construct a lane, that it broadcasts to all other lanes where it wants to connect with it. And right now, it is true that it broadcasts to all other lanes, and that probably will affect performance at some point. But the reaction to this broadcast is actually very simple, and all the other lanes can very quickly figure out whether they even are in a close vicinity to the lane that sent the broadcast or not. So they can decide very quickly whether they should even do any calculation. So far I didn't notice that to be a performance bottleneck, but it might actually be one in the future. And the solution for that is one that I wanted to have in general, where actors cannot just broadcast messages to all other actors of a certain type, but that you kind of have a local, like spatially local broadcast where the lanes know roughly in which square of a grid, for example, they're in, and then they only broadcast messages to other lanes that are in overlapping grid squares, for example. That would be a very simple optimization. I already have a bunch of optimizations that work like that in other parts of the code that are not related to message sending, where I just use a very simple grid as a first approximation to figure out which parts of plants interact with each other, for example. And as simple as it is, that's actually very effective in increasing the performance. Okay, so let's see where car lane implements connect. So that's also that's implemented in construction. So let's see what a car lane actually does when it gets a connect message. It gets the ID of the other lane, start and end and length. And then, yeah, what it does is it looks at a bunch of cases where, like, if the start of the other lane is roughly equal to the end of ourselves, well, then we will consider this to be our next lane. And conversely, if the end of the other lane is roughly equal to our start, then we will consider this to be a previous kind of incoming lane. And we add the lane into our list of connected lanes. And if the other lane actually wants a reply back with our information, which is being set with this reply needed parameter here, then we, well, send back our information. We kind of symmetrically send a connect message back. So that sounds already very similar to what we want to do with the sidewalk. So once again, we use copy paste, which is not great and can probably be simplified later, but for now, let's just get it to work. So let's see, that's actually implemented directly below spawn and connect. So let's do the same for the sidewalk. So what's different? Well, the other one is not a car lane, but it's also a sidewalk ID. But we get the same kind of information. The difference here is that this is not a car lane interaction in all of these cases, but a sidewalk interaction. But I think other than that, it should work exactly the same. We probably need to import that. I think this one doesn't have the, oh no, it does have the green. Do we really care about that? Maybe not, but let's leave it the same for now. Let's go back here. We don't care about the previous length for sidewalks though, that's slightly different from roads, but apart from that, I think it's pretty good. Here we can already see some hints at that. Well, when we do connect to another lane, we should probably tell Pathfinding about that. We didn't at all yet implement that sidewalks actually also create a pathfinding network, but I hope that that should be relatively straightforward. So you can see as we go here, we kind of create more bugs as we fix others, and it feels a bit like a game of whack-a-mole, but like I said, this will perfectly guide us through implementing all the things we need. So what doesn't it like about that? Oh, so that's so because these are of a different type, we actually need to cast both of these into something else, and what we want to cast them into is obstacle container ID. Let's see if it's happy to do that for us automatically. Why not? Because we didn't implement obstacle container for sidewalk yet. Okay, again, one bug removed, one more to go. Apparently we don't need these imports here. So why do we need a constructible ID here? Oh boy. Yeah, we actually don't want an obstacle container ID, we want this to be a constructible ID. And then it will complain that sidewalk is not constructible yet, which is also something that we still need to implement. No, is that not what it wants? Constructible ID. Oh, because it needs to be specified that it's for Citybound prototype kinds. All right. Okay, so here now we run into the issue that we want this to be both a constructible ID as well as an obstacle container ID. So now we have to ask ourselves the question whether all obstacle containers are also constructibles. Maybe. Yeah, I really need to come up with a way to represent IDs for something that's two different traits at once. I don't know how well I want to do that now. Okay, so let's do it cleanly. Let's split it up. So first we create the car lane IDs. Where we only create the car lanes and we keep the original type. Otherwise, don't create it. And then we separately create the sidewalk lane IDs. See, the thing is that here we are creating the different kind of lanes that exist on an intersection. So both like the lanes that connect the incoming and outgoing roads, as well as the sidewalks, which might either just be like the corner curbs or the actual pedestrian crossings going across the road lanes. We create them both. They're of slightly different types. And we need to create them we need to create them separately so we can do all the proper type connections. So the connecting lanes, values, flat map by group, like we do up there, iterate over the group, and then do filter map over the lane prototype, yes. And we want to get some stuff from that lane prototype, like this. And we match it. And basically now if it's a sidewalk, then we want to, okay. Then we want to spawn, well, a sidewalk. So instead of a car line ID, we do sidewalk ID, spawn and connect. Remember what we implemented earlier. Otherwise we return none because here we only want the sidewalks. And we actually don't want to specify the type just yet. We just collect those, match, collect. Is this one? Where does this one stop? Neither one. Another one, is that true? I think now it's correct. The types don't quite work out. Let's give it a second, see if it comes up with the correct types. No. Why is that unknown? This returns. What do you return? So this should be a vector of car lane IDs. Let's tell it that explicitly and see if it agrees. And similarly, this should be a vector of sidewalks IDs. Okay, well, it agrees with that from the looks of it. So basically now we want both of these IDs together as obstacles and then as constructibles. So as obstacle containers. So we have the car lane IDs, iterate over them, map into an obstacle container ID into And then chain after that the sidewalk IDs. Let's rename that to just sidewalk IDs. Iterate map like that. And then collect as a vector. Okay, let's see if it likes that. Still no. Okay, because we didn't really define that sidewalks are an obstacle container, that's fine. I just quickly want to answer one chat question. Cody Watts asks, have high occupancy housing been mentioned? Well, I certainly want high density buildings. What blocked that so far was that I didn't really have the procedural building generation, which made it very cumbersome to basically create the procedural models for bigger buildings. But that's almost done now, and I'm like in a process of recreating all the existing building models, and that's a lot quicker than the original way of writing the rules for constructing the buildings by hand. So I hope that with that I can also very easily create some simple rules for higher density housing, higher density business and industry. And then all that's left is really just the UI to specify which zones should be higher or lower density. And then it's just a matter of creating the corresponding like household types and building types which contain more households, and everything should just work out naturally. So that's kind of the plan for that. I see that we're already running for almost 45 minutes. So I would suggest that we take a 5-minute break until like 55 on my clock. If you have any questions in the meantime, just post them in chat. I will answer them after I'm back. And then we'll continue right where we left off, all right? Okay, and we're back. Did you have any questions in the meantime? I'll put you on the second screen again. Feel free to ask whenever you have a question. And let's continue here. So again, this is just complaining because sidewalks are not implemented as obstacle containers yet. So we also want to have it as constructables. And we do a very similar thing where we do car lane IDs into either map into a constructible ID. And we chain our sidewalk IDs into iterator map. You can see that I have this extension here, which kind of like very intelligently suggests something. I already forgot the name of it, but it's really amazing. It basically uses machine learning and analyzes all your code. Oh yeah, right, that's top 9. It can do autocomplete for any language, and it feels like it kind of understands the structure of your particular code base. And I think it's also fed with like a lot of code bases from other projects. And most of the time it does like really long autocompletes that actually make sense. It feels scary sometimes how good it works. You have to be careful and really check what it suggests, because sometimes it is wrong and you can easily get mistakes like that. But when it suggests the right thing, it can really save you a lot of typing in a cool way. So we also convert the sidewalks into constructible IDs and collect them as a vec. See it again auto-completed already exactly what I wanted to type. Let's do this. So here we iterate over them as obstacle containers, and then we return the constructibles. So we will need to specify those again. Again, it automatically knew that that's what it needs to do. Oh, here it wants a CVEC. Okay, so this seems clean and correct and better now. So now we can create intersections containing both car lanes and sidewalks. We ran a couple times now into the issue that we didn't implement obstacle container for sidewalks yet. So let's maybe go ahead and do that. Let's see where we implemented obstacle container for car lane here. All right. That's quite a lot. So again, let's go ahead, copy all of that and use the same implementation for sidewalks, and then just go through it step by step and see what applies. So let's see. So let's go to the very top, implement obstacle container for sidewalk. I think for now we assume that sidewalks are as wide as a normal road lane, so we can keep this. Let's give type checking a second to catch up here. Okay, so this all apparently looks correct for it, and we can even keep the logic the same. But here it needs to be a sidewalk interaction. And I think here we again need to check that the other thing is actually a car lane, because sidewalks can only really conflict with other car lanes. Like we're not considering people running into each other yet, but they should correctly interact with roads. So let's see here. No, where did we just use that? We used that for the, I think was the connect of. Here we want to do the same kind of thing. So back to our implementation of sidewalk connect. So we again check that this is a car lane. So basically that's just a very elaborate way to try to typecast the other ID. Wait, we shouldn't do that in connect. We should do that in what we just wrote down. I'm getting lost with the files. They're a bit all over the place. So we were implementing obstacle container for sidewalk here. When we connect the overlaps, we want to make sure that the other thing is actually a car lane, not just any obstacle container, because our sidewalk intersection expects a car lane here. We don't care about can weave. Pedestrians can never weave between cars. The cars have to stop completely and the pedestrians have to stop completely, so we can get rid of this calculation. Because basically with roads, if you have conflicting lanes, if they intersect at like an orthogonal angle, the cars actually have to stop if there's a car from the other lane on the overlap of the two conflicting lanes. But if you imagine like a kind of flatter angle like this, like you might have on a highway on-ramp, the cars can actually kind of weave in between each other, even though they're not completely merged into the same lane yet. And that's why we had this calculation for the lanes. If they conflict, the cars might still be able to weave. But for pedestrians, we just say they can never weave with cars like that. Would make sense. Okay, so this is probably correct so far. Just need to do this, and we can continue with this one here, add obstacles. That's fine. We just add the obstacles to ourselves. If we disconnect from another obstacle container, if we disconnect from another obstacle container, we want to basically check which kind of interaction is it. So which cases do we have? Sidewalk interaction. Well, if it's a conflicting one, that means, what do we have here? In conflicting, well, we have the conflicting lane that we care about. So we want to keep it only if conflicting is not the other ID. So we want to remove all, we want to keep all conflicts that are not the one we're disconnecting currently. That should make sense. What about if it's a next sidewalk, like a following sidewalk? Here we just have a next, and we can do the same of, well, is the next something different than the one we're disconnecting? And same for previous. And you see it, like this extension already machine learned the kind of pattern that I'm writing here, and it can intelligently suggest quite far ahead what I was trying to type. It's really crazy. How are you guys doing? Do you have any questions? Are you still with me? Did I lose you? Seems like you're still there. Okay, let's move this back to the other screen and continue. Oh, I should probably make those curly. Planet is still here just enjoying me ramble about code. Yeah, that's roughly what it feels like for me. Yeah, this is VS Code, indeed. And I'm since today using the Rust Analyzer extension for Rust, which is giving us much faster typing feedback than RLS did previously. Let me know if you have any other questions about the setup. I'm happy to share details. Okay, so something interesting again that we, yeah, this, if we disconnect a lane, a car lane, there might be cars that were trying to get to that lane, and now if it's disconnected, we need to tell them to kind of prematurely finish their trip with an error code. It's not handled very gracefully. It's basically what should happen if you destroy a road while someone is trying to go there. The idea is that that happens rarely enough that in that case you can just kind of reset the car trip and the car just vanishes. It's not super beautiful, but then again, it's kind of an exceptional thing. So we need to do the same for, well, pedestrians. So for pedestrian, in the case of sidewalks, micrographic has pedestrians, not cars, and they should also have a trip. And again, we finish the trip with the kind of error trip fate hop disconnect. That's what it's called. And again, this is not implemented yet, both this and this, because we didn't implement sidewalks being part of the pathfinding network yet. Okay, so let's see this finalize. Lanes have this finalize method, which I guess we will also need for sidewalks. What does it do? It finishes. So this is actually what should happen to the cars that are currently on the road that we're destroying. We will need to do exactly the same for sidewalks as well. So, well, implement sidewalk on. It's kind of the same in this case, just I think that should do, and this arrow will guide us later to implement sidewalk pathfinding. What happens to people in the car when you unbuild the road that they're in? Well, as of right now, it doesn't really consider people to be in the car. It's more like the people participate in a trip that happens to have a car associated with it. When the trip succeeds, then the people are kind of put into the destination building. Same if the trip has an error, kind of different things can happen. Either they are teleported to the destination building anyways, in order to not have a bad effect from like roads being disconnected, or alternatively they might be transported back from where the trip started and they will kind of retry to do the same trip or maybe do a different trip if their situation has changed in the meantime. So the people aren't really in the cars. Just when the people want to go somewhere, they create a trip and a car is spawned that's associated with the trip. The car navigates the road network, and once it arrives, it kind of tells the trip that it's done. That's how it works. The nice thing is that this will allow us to easily extend this to pedestrians, because people still start a trip in the same way. It just happens to be done by a pedestrian instead of by a car. That's kind of how it works. Okay, so we have this. So that should have fixed one more error, probably created a bunch more. So let's just look again through the files. So maybe let's fix a bunch of errors here next in the like tick method of sidewalk, which is the method that gets called every simulation step to kind of update the physics of whatever we're doing. You see that on some of the steps we do a pathfinding tick, which basically updates the navigation network and calculates shorter routes if there's some new ones. For example, because if we added new sidewalks and they connected, now there might be a shorter route or some route might stop existing. So from time to time, we do this pathfinding update. And we will get to pathfinding in a second, because I feel like now we have a bunch of errors relating to that not existing. So you see, as we work our way through these errors here, they actually hint at us which bigger topic we need to implement next. But here's a kind of weird problem that I didn't really expect. Why is this? So I guess we want to destructure that. We only care about the obstacle, not where it came from. That's so weird. Did I copy that code from somewhere? Why is it wrong here but not in another place? Yeah, that's really odd. I don't know why these were errors here. So, okay. Here, that's just a typo. That should be pedestrians plural. I'm not sure. I think in Rust we only use 2 dots to do that. So what's really in a pedestrian other than an obstacle? Or all of this stuff, okay. I guess we can't do that multiple times, okay. Oh, I'm low on battery. Time to move over the charger. No, this should be correct. Okay, so that's a bunch of errors come here. So I would suggest that we move on to pathfinding. So I guess we want to just do the same thing again, implement the same for sidewalks. And I really promise at this point that I will go through all of that and see if we can't reuse a bit more of that code later. So now we officially make a sidewalk a link, which is basically a connecting thing in the pathfinding network. So here we basically say that, okay, which kind of route segment is a sidewalk? Well, it has a distance that corresponds to the construction length of the sidewalk. And there's a bunch of other stuff that explains basically which roles a sidewalk can play in the navigation network. So let's see here. I don't understand why it doesn't show me errors for that. This doesn't exist. Why is it not throwing any errors here? That's really weird. useful. Let's do a match here instead. If it's a sidewalk interaction, next. Come on. Then, well, same for previous. And otherwise, we don't care about it. I think that should be correct implementation of that. Then we need to tell the pathfinding if we have a sidewalk, what are its successors in the network. So here we only need to look at sidewalk interaction type next. I guess we need to import that. And we tell it that, well, if we have a next sidewalk, then that is a successor link, and the connection cost is, well, our own length. In order to get to that other sidewalk, you first need to walk along this sidewalk that you're on. And very similarly, we will define predecessors, which is exactly the same thing but backwards. So, okay, let's see if I can fix some errors by forcing it to regenerate this file. That's weird. I thought that that's exactly what we're implementing here. Oh, I guess we need to import sidewalk. That's why we didn't get any errors earlier. Probably will get a bunch more errors now. And now I need to again regenerate this. Oh, wow. It feels, maybe I've spoken too soon, but it feels like the total number of errors just went down. No, that's not true. That's still. Why is it not implementing this if I do this here? Oh, because I need to import sidewalk ID as well. Where did it even import sidewalk? Yeah, I know that. Oh, all the way at the bottom here. That's weird. So this function here is again kind of dealing with a special case where a car was trying to go somewhere and it already had a route in mind, but then for some reason that route got destroyed, maybe because like a road further on was destroyed or a shortcut was added somewhere, so kind of the route, the destination that it wants to go to doesn't really exist anymore as a destination for where it currently is. So in this case, we need to, again, stop the car's trip, in our case, stop the pedestrian's trip with the error route forgotten. And we kick, basically, we remove all the pedestrians that can't get to their destination anymore from where they currently are by canceling their trips. So that should work exactly the same way. Then you see in a couple places we're talking about these rough locations where basically a destination in Citybound is defined as a lane and an offset along the lane. So the lane acts as a rough location. For example, a building is associated with the lane and then offset along the lane. And very much in the same way we want sidewalks to work similarly. So what we will do is actually connect a building to both a sidewalk and a lane so that you can exit and enter the building both as a pedestrian and as a car. So I think we have the implementation further up here for the lane, and we just want to do exactly the same for the sidewalk to make this stuff work. And yeah, we basically is represented by a point in the center of the road, or in this case, in the center of the sidewalk. It says here YouTube is not receiving enough video. Let me check if we dropped a bunch of frames. Let me know if the stream was like broken at some point, and if yes, if you could tell what that was caused by or what I was doing at the time. Otherwise, I assume that it's fine again. Okay, so why is it complaining here but not in the next one? I guess, okay, whatever, let's do it the explicit way. Into link ID, into next. And same here. Do I really need to import that? Oh, I guess I need to dereference that. So one thing that we can quickly do before I forget it, and just so we have it in the code and get a bunch more errors that will again guide us the right way, we could go to buildings and already define there that a building should have not just a location for a road, but also a location for a sidewalk. So again, that we can enter and exit the building as a car or as a pedestrian. So let me already change that here and then see which places it affects. So let's start calling this a lane location and this a sidewalk location. And since we renamed the fields, we should now get a bunch of errors in all the places that's used. So let's go through a bunch of them. In the beginning, when we first spawn a building, it doesn't have a location yet, but it will actually, again, using broadcasts, kind of call all lanes and sidewalks that exist, and then they will kind of organically find the one that's closest to the building, and this is then considered kind of the entry point for the building. Of course, with a given threshold, so that a building can't be like super far away from a road and still be connected to it. Right now, if you remember how Citybound looks, cars actually disappear on the road right when they're next to their destination building, and will be the same for pedestrians. A little later on, we can actually implement that the car goes into the like yard, and that you can see the pedestrian walk up to the entry door of the building. All that we need to do for that is basically implement tiny automatically generated roads on the building lot itself. I just didn't do that yet because that might create quite a lot of performance overhead with like the intersections that these tiny roads and paths on the buildings would create with the main like traffic ones. So there needs to be a kind of lighter weight interaction, so we don't have a million intersections everywhere. And I just didn't want to figure that out. So for now, it's a bit simpler where the cars and pedestrians will just disappear when they're next to the building. Okay. I would suggest that we take another 5-minute break now, and then we'll do another maybe half an hour section of coding. Again, if you have any questions, feel free to write them to me during the break. And then I'll call it a day for today. I have to say I'm having a lot of fun. I feel a lot more focused this time, and even though we're kind of progressing slowly through all of these bugs, I think we're doing exactly the work we need to do to make sidewalks work. And I hope it's at least somewhat interesting for you to follow along. So again, see you in 5 minutes, let's say 38 on my clock. And let's continue then. Okay, and we're back. So Planet 10 asked a very nice question, how I'm doing. I would say personally I'm doing pretty great. In a more general sense, I'm a bit worried by how people are kind of relaxing a lot about quarantine. Like, at least in Germany and Bavaria, the government is now relaxing a lot of the restrictions a little bit. But I feel like people already completely don't care anymore and aren't careful. So yeah, that's a bit scary. And I'm pretty sure there will be a second wave. I'm actually really thankful to be, as a programmer, in a position where I can actually work from home for a quite extended period of time. But yeah, I think it will take quite a lot more time before we have all of this behind us. Okay, let's do just a little bit more here. Remember, you can ask me questions at any time you want. So we just added here two buildings that they have both a lane and a sidewalk location, so that you can enter and exit them both as a pedestrian as well as a car. And let's just continue to go through what that means. So that just means that, for example, when we finally destroy a building, we have to tell the pathfinding network that this building doesn't exist anymore. And now we will need to tell it not only that it doesn't exist anymore as a location attached to a lane, but also as a location attached to the sidewalk network. Let me just quickly answer a question here from Dalaj Konik, I guess. Who says, I don't know Rust, but how is the thread architecture solved here? So funnily enough, Citybound actually still runs single-threaded, but because it's implemented as an actor system, which means that kind of every entity in the game, like a house or a household or a person or a road lane or a sidewalk, are implemented as like these independent things, which are called actors. The terminology overlaps a little bit here with the meaning of actors that like SimCity used, where they just mean like some simulated entity, but I mean the like programming meaning of actor, which again means that the main thing is that all these different simulation entities work independently. Most importantly, they can't inspect each other's state directly. They can only send each other messages. So everything that happens in the game where these things need to interact has to happen through message passing. One example that I like is when a car reaches the end of a stretch of a road and goes onto a different road, the first road actually sends a message to the second road that, hey, here, have this car. It just finished going along me and it will go along you next. So it sends this like transfer car message to the other road. This is a good example of actors. The first road can't just put the car onto the other road. It has to send it a message. The other road accepts the message and then has the car itself. Why do I explain all of this? Why is it important, or why is it nice? It's nice because it means that the roads don't care at all where they are run, where they are simulated. They could be simulated on the same processor core and just send each other a message very quickly. They could also be simulated on different processor cores, and they can still send each other a message, but without needing any locking or synchronization. So that's very fast. And even cooler, the two roads don't even have to run on the same computer. And that's actually something that Citybound already kind of supports, or like the code actually completely supports it. I just need to finish some UI around that. So you can run Citybound on several computers and have some of the city exist on one computer and some of the city exist on the other computer. And it might be actually completely chaotically distributed. Like this building is on this computer, this building is on the other computer, this road is here and there. But since the whole simulation regarding the interaction between the simulation entities is implemented using message passing, well, you can send these messages over the internet as well. So Once the car reaches the end of one road, this transfer car message could be sent all the way across the internet to the other computer, and it would still just work. So it's actually already distributed and parallelized, but in a kind of ironic way, I parallelized it across machines before I implemented the parallelization across cores. So kind of solved the hard problem first, and then parallelizing it onto several cores will be way simpler than onto several machines, obviously. And the message passing should be just as fast as on the single core. So we kind of just at some point, whenever I get around to do that, get like a 4x to 8x performance increase, hopefully, because like literally everything in the simulation parallelizes that nicely. There's one part though, to give a little bit of a disclaimer, that I didn't manage to break into little actors yet, which is the planning system, where like basically the plan that you're editing in the city is one huge actor, and that works way more like a traditional single threaded program. But I already have some ideas of how I can also break that up into individual little actors, and then that should also be parallelizable. But this is like I guess this was a very short summary of why the Citybound architecture is actually pretty unique and special for games, at least. Okay, so let's continue here. How did we call them again? Lane location and sidewalk location, and we basically just need to do the same thing twice. We need to remove it from the lane network and from the sidewalk network. What else? Oh yeah. So a building is an attachee, which means something that you can attach to a network link. So, okay, let's see here. I'm not quite sure how to distinguish here whether the building is being added or removed as what. Because here we just know that it's a location. So I feel like we need to introduce somehow a notion of the navigation networks being separate, because a pedestrian can't become a car and vice versa. So these are completely separate, and we might need to communicate kind of the flavor of the navigation network that we're talking about, I think. So let's maybe look at the attachee trait. And yeah, I feel like that's something that has to do with the attachee, because they are the entry and exit points, kind of the sinks. So I feel like we need a parameter here. Let's call it a network flavor, even though that's a bit silly. And then we will have to implement that somewhere. So yeah, let's just do that here. And we might need this in several places. So we have a car network and a pedestrian network. Right. Now if we go back to the building, if our location changed, so now we actually get this network flavor. I think I just need to implement a bunch of stuff here. This needs to derive copy clone. Hannes just joined in. He's asking, are we at a point where stuff is running yet? No, not quite, because, well, and again, the sidewalks touch a lot of systems in the game, and we're just going through them one by one, kind of adding all the functionality that roads have onto sidewalks one by one. Right now, we're basically changing the building implementation so that a building can be connected both to the road, the car network, as well as the pedestrian network. So that's kind of what I'm doing. Huitzi is asking a really good question where, like, if you think about it, if we had a perfect simulation, only pedestrians should be able to enter a building, at least after parking is implemented. And that's, in fact, exactly my longer term plan, where when I implement parking, it will be exactly like that, that only pedestrians can really enter a building, and that the parking will kind of act as a gateway between the car network and the pedestrian network. Obviously with some more complicated logic, because we want people to go back to exactly their car which they parked earlier, and we will need to keep track of that state of like what is their car and where is it parked, somewhere in the trip, I guess, or in the household. So you can see that that's already quite a bit more complicated. For now, we'll take it a bit simpler, not worry about parking, and we just model it in the way that pedestrians and cars can enter buildings. Make sense? Okay, so, whoops. So now by introducing this network flavor, we see that that kind of needs to be carried throughout everything. And I guess, okay, everything that wants to act as a link in the navigation network has to have this pathfinding core where, like, for example, a lane or a sidewalk remembers which location it is, which routes it has, like where it's connected to. So here we will also need to associate our link, which has a pathfinding core, with the network flavor. And that will create a bunch of more errors. I think you get the idea. So I think we might quite good progress with implementing all the standard, like construction, connecting sidewalks to other sidewalks and this kind of stuff equivalently to roads today. There's quite a bit more to be done in terms of implementing pathfinding, or like rather connecting sidewalks to the pathfinding logic and the buildings. Again, I will try to get some of that done off stream without like advancing so far that we completely jump ahead next time. Still, my goal really is to get something on the screen. I can't really promise you when exactly that will happen, but definitely watch out for the next live stream where we will continue with that. I would say let's use the last 10 minutes to just answer any other questions that you might have. And yeah, both what we did today and what we're doing in general. I have to do one thing, which is to plug my GitHub sponsorship. I've been told that I don't do that nearly enough, because there's actually something very cool going on, where I kind of told a while ago to people who support me on Patreon that they should move to GitHub, because Microsoft, who own GitHub now, is doing a very nice thing where you can get sponsored on GitHub. Let's see, how can I show you that? So if you go to github.com/sponsor/aplay, you see my profile here where I explain what I use sponsorship for. And you can choose if you like Citybound, if you like these live streams, if you like what I'm doing, and you want to give me a bit more opportunity to spend more time on it, and to justify like not having to work a day job, for example. Just like on Patreon, you can contribute a monthly amount here. Again, please only do this if you really feel comfortable with that and if it feels worthwhile for you. And the neat thing is that for the first year, which is still ongoing, Microsoft will match your donations, which means that if you donate, for example, $5 a month, I will get your $5 plus another $5 from Microsoft. And they do this up to an amount of $5,000 within the first year. So by donating on GitHub, you can actually kind of donate double. And I really, really appreciate it. But again, it's just if it's actually easy for you to do. And I'm just happy mostly to have all of you guys' interest. And yeah, also let me know regarding the live streams if you have any feedback on how I did the most recent ones, because like the last two were quite code intensive, as I mentioned, and kind of apologized for several times. But it seems like some people actually just like to listen to me rambling about the code that I'm doing. Obviously, it will be more interesting once we have something on stream. But yeah, let me know if you want me to do anything else in the live streams. If you want me to do more Q&A, it seemed like today there were a little less people, so that's not as interesting to kind of show. Or if you can imagine any other kind of activity that I could be doing in the live streams that is interesting for you. It's first year of my campaign, although I did join quite early when they unlocked that. I think I even I applied to be in the beta for that, and now they rolled it out wider. But I think I started my campaign on GitHub started in November, so it should at least be, or October, so it should work at least until next October or November. Yeah, so again, if you have any ideas for the streams, what else I could be doing, I would be very happy to hear your feedback. And I think I will actually check myself after the stream is recorded and done, whether the audio quality with the AirPods ends up being better or worse than with the big microphone. This is obviously a lot easier for me to set up, and maybe means that I can do live streams a bit more spontaneously or often. But let's see. Yeah, I'm really glad, Planet. I really hope that it's inspiring. If you want to, feel free to tell us what you're working on. Thank you. That's very nice. I'm very glad to hear it. Maybe while you guys think of some other questions that you might have, just a general topic, like I would say one of my overarching goals with Citybound is, apart from any particular topics that I'm currently implementing, like procedural architecture or now pedestrians, I really want to open Citybound up for contributions for open source contributors. I've had really good contributors in the past who implemented quite a lot of stuff, which really humbled and impressed me, but they were only always able to kind of work on the most generic parts of Citybound, like kind of helper libraries, fixing problems with third-party libraries, that kind of stuff that's really not specific to Citybound itself, which was always really helpful and actually saved me a lot of annoying work even. But it's also a signal to me that kind of the core of the code base that is specific to Citybound is so complex and so convoluted and not documented enough that it's really hard for someone external to just dive in and learn. So again, that's what I meant with the big topic. The big topic is that I want to make it more approachable, but I'm not sure yet what that even means for a code base as big as Citybound. I feel like a lot of the code is very visual in nature and would really benefit from having some diagrams associated with it, just like even how the lanes work. In the first live stream, I drew a lot of pictures that I think made the abstractions much clearer. And I would love for those pictures to kind of exist somewhere way closer to the code, so that someone could browse kind of the code and almost like this nice encyclopedia of how Citybound works at the same time. I think that would really lower the barrier to modding or even helping with Citybound. But yeah, the tool for that doesn't really exist yet, and I kind of want to see if I can build this kind of more informative code base and really make this a more open project. That's kind of, I feel like that's a multi-year project in itself, but it's definitely worthwhile because I want Citybound to not just be this one concrete thing that I have in mind, but also to be a platform for any kind of city simulation project. Let me read what you guys wrote. Definitely a lot less noise. That's good to hear. Dutch Conic is working on cellular automata. Yeah, I love those, and I love falling sand simulation games. It's super cool because with some pretty simple like particle interaction rules, you get really complicated behavior. Planet is working on a new website for his church and making sure it has a better user experience. That's really cool. Okay, cool. Well, thank you all so much for joining me today. Again, I hope that you enjoyed it. I will, like always, announce a doodle for the next live stream. It's kind of unpredictable right now, but I hope that with the doodle we have a nice, somewhat democratic process of finding times that work for a bunch of people, so we get nice interaction during the live stream now. For everyone else who's watching this live stream later, thank you. I hope you enjoyed it as well. And let me just reply to a couple comments here regarding to what I said. Dalach Connect says he never got the modding part. Must be extremely hard to be able to create dynamic modules depending on mods. So the way I want to do it with Citybound is actually that a mod would be a complete fork of the game, whereas a modder, there isn't even like a modding API that defines what can and can't be modded, but you just fork the game and you can do whatever. That being said, there's some aspects of the game that I will abstract out and which will use kind of domain-specific languages, like, for example, the procedural architecture, where the architecture rules for a building are written not in Rust, but in a special language just for that. And adding a new architecture style is actually as simple as just adding a new file and using this language to describe it. And then that just works with the game. So some aspects of the game will be really easy to mod using these specialized tools that even non-programmers, I would hope, will be able to use to create new content, while you're still able to mod some like quite core parts of the game by just completely forking the game. And even if you do that, I mean, it would just be a git fork, and you will be able to merge back any update that the game gets. You will easily see where it conflicts with new versions of Citybound, and I hope that the workflow for modders would be quite straightforward to always stay compatible with like main Citybound. Yeah, like I said, Markdown in the comments would definitely help, but pictures would be even better. Okay, I'll wrap it up here for today. See you all soon. Have a good night or rest of your Sunday. Stay healthy, be careful out there, and have a nice time. Bye.